Welcome back, everyone, for another deep dive. AI is always advancing so fast, it's hard to keep up.
Definitely. Yeah.
But today we're going to be looking at one of the most fascinating areas, I think, at least to me, of AI research. Video understanding.
Really exciting stuff.
Yeah. So, it's not just about AI that can watch videos, passively. It's about AI that can actually understand what it's seeing, grasping those like intricate plots and relationships, like you or I would watching a movie.
Yeah, it's more than just processing pixels. It's like actually comprehending the story, the narrative.
Exactly, exactly. And to kind of guide us through this pretty complex landscape, we're going to be dissecting this brand new research paper.
Hot off the press.
Literally. It was published just yesterday, December 16th, 2024.
Wow.
And the paper's called Apollo, an exploration of video understanding in large multimodal models. And it's by some researchers at MetaGen AI and Stanford University.
Really a powerhouse team. So, I mean, this is significant work coming out.
Oh, yeah, definitely. And, they don't just lay out the challenges here. They're actually introducing like a potential solution, and they're calling it Apollo.
Okay.
Which is the name for this new family of video understanding AI models. And the results are really impressive. I mean, they're actually even outperforming some models that are way bigger than them, which is really interesting.
It's really pushing the boundaries of what we thought was possible, especially at that scale.
Yeah, for sure. So I guess the big question is, why should anyone listening care about AI understanding video? I mean, this sounds cool and all, but like, what's the big deal?
Well, think about it this way. Like, how do you search for information online right now?
Keywords, text, the usual.
Exactly. But now imagine if you could, just show your computer a video clip and ask it these really complex questions about what's happening.
Yeah, like, I need to find that one specific moment in a long lecture or something.
Right. You just show the AI a quick visual cue, and boom, you're there.
Yeah. Or, okay, what about entertainment, Like, imagine interactive movies where the story actually adapts to what you choose to do, and it's all guided by an AI that actually gets the narrative.
Yeah. And can predict what you might do next.
Yeah.
It's like taking storytelling to a whole new level.
Yeah, that would be crazy. But, before we get too carried away with all the potential, all the cool stuff, this paper also tackles some of the big roadblocks, the things that are holding this technology back. And one of the big ones they talk about is scaling consistency.
It sounds complicated.
It is kind of a mouthful, but it's basically asking the question, does making an AI model bigger, like just adding more parts to it, automatically make it better at understanding video?
Traditionally, that's been the assumption in AI, right?
Right.
Bigger is always better.
Right. But this research is actually suggesting that it's not quite that simple.
Especially when you have all these different components working together, like in these, complex video models.
So that's where this scaling consistency idea comes in. It's this idea that if you make smart design choices on smaller models, like figure out the best foundation,
Right.
you can actually transfer that to much larger models. And that could be, think about how much more efficient research could be, because you wouldn't always need to build these gigantic models to test out new ideas.
It's a much more sustainable approach in terms of resources too, right? I mean, training these massive models takes a ton of energy and computing power.
Yeah, absolutely. So another, big hurdle they talk about is how these AIs actually, like, how do they learn from video?
Yeah, how do you teach a machine to understand a movie, basically?
Exactly. You might think, oh, just show the AI a bunch of frames from the video and it'll figure it out. But it's not that simple.
It's more nuanced than that.
It's not that easy. The way what they call sample a video, like which frames you choose to show the AI, can make a huge difference.
Like, imagine trying to understand a story by just reading every other sentence. You might get the gist, but you're going to miss a lot of the details, the connections between events.
Yeah. So this paper shows that doing what's called frames per second sampling, where you show the AI like a consistent stream of frames, it's way better, because it maintains that sense of time, the flow.
It's like watching the video at normal speed, right?
Yeah.
Instead of like in slow motion or with jump cuts.
Exactly, yeah. And then there's this other thing, this trade-off between the number of frames per second and the number of these, what they call tokens?
Tokens.
Yeah, it's kind of like, think of them as like little pieces of information, like little Lego bricks that the AI uses to represent what it's seeing and understanding.
So it's not just about the raw visual data, but how that data is broken down and analyzed.
Right. And then there's this whole thing about visual encoders.
Okay, so this is like the eyes of the AI.
Yeah, yeah, basically. It allows it to like actually see what's happening in the video. But what's really crazy is that they found that some encoders that were originally designed for still images work surprisingly well for video.
That's counterintuitive. But, I mean, think about it. These image encoders are already really good at recognizing objects, faces, understanding a scene, all within a single frame.
So even though they weren't specifically designed for video, they can still provide a lot of useful information.
Right. It's like they have a good foundation in visual recognition, and then they build from there.
Yeah, exactly. But of course, there are certain things that these image encoders struggle with, like, estimating speed or
The
direction.
things that change over time,
Yeah,
the dynamism of
well, you're
video.
right. And that's where video encoders come in. And what they found was that this combination, this like pairing of a strong image encoder called, it's a mouthful, Siglip SO400M with a video encoder called Intern Video 2.
Wow. Okay, so they're like combining the best of both worlds.
Yeah. It's like having this, I don't know, this dream team of video understanding.
So the AI can see the video, but then how does it actually make sense of all that information? Because we're talking about a mass amount of data,
Right. Yeah. And it all needs to be condensed without losing those important details.
like summarizing a giant textbook.
Yeah.
You want the key points, but you can't get bogged down in every single sentence.
Right, exactly. And that's where these resampling techniques come in.
Resampling.
Yeah, it's basically like the AI's way of creating its own Cliff Notes version of the video, highlighting only the most important parts.
Makes sense, yeah.
And they found that this one method called the perceiver resampler is really effective.
Okay, so like the AI is a speed reader, basically.
Yeah, kind of, yeah. And then they talk about these timestamps, like the chapter markers you might see on a DVD.
Right, right.
Adding those between clips can actually help the AI understand those relationships between events.
Interesting. So it's not just about what's happening in each individual frame, it's about understanding how they all fit together over time.
Right. And all of this, how the video is sampled, the encoders that are used, even the timestamps, it all feeds into how well the AI can ultimately understand what it's seeing. But before we get into like the specifics of these Apollo models, we need to talk about benchmarking.
Which is how we measure how well these models are actually doing, right?
Exactly. It's like, figuring out a fair way to test someone's understanding of a book, making sure they actually read it and didn't just skim the Wikipedia page.
We've all been there.
And the paper points out that a lot of existing benchmarks in this field, they're kind of misleading. They act like they're testing video understanding, but you can actually solve them just by looking at a single frame, like a single picture.
So it's like judging a book by its cover, not actually reading it.
Exactly. And they're super time consuming too. It takes forever to run all the tests.
Right, and you end up with a lot of redundant information. It's really inefficient.
So the researchers behind Apollo, they created their own benchmark called ApolloBench. And it's this really carefully curated set of tests that focuses on like true understanding of the video over time, like figuring out the cause and effect relationships between actions.
So it's more challenging for the AI. And it actually tests what we want it to be able to do.
Right. And it's much faster to run too.
That's great. So we've got the challenges, we've got the techniques, and now we've even got a better way to test these models. So how do these Apollo models actually stack up?
Yeah. Let's dive into that.
Well, they put them through a whole bunch of tests, these benchmarks, like Temp Compass, MLVU, even this thing called the perception test.
Okay. Like obstacle courses for the AI.
Pretty much, yeah.
Uh-huh.
Testing their ability to, like, answer questions, about a video, figure out how things are related, and make sure they're not just, like, memorizing stuff,
Yeah.
actually getting it.
Yeah, like actually understanding what's happening. Okay.
And even the smaller Apollo model, this one's got, like, 1.5 billion parameters.
Okay.
Which sounds like a lot. But for these types of models, it's actually on the smaller side. It's already beating out some models that are way bigger, like Phi 3.5 vision, and even some like 7 billion parameter models like long VA7B.
Really? So it's like outperforming its weight class.
Yeah, exactly.
That's cool.
And then there's Apollo 3B.
Okay.
This one's going up against like the heavy hitters,
Yeah.
the 7 billion parameter models. Oryx 7B, Kangaroo, VideoXL 7B, all the big names.
And how's it doing?
Okay, so this is where it gets really interesting. Apollo 3B is actually like consistently beating them.
Really?
Yeah. For example, on MLVU, which is this really tough benchmark, tests the AI's ability to understand like a lot of different aspects of a video. Apollo 3B gets a score of, get this, 68.7,
Okay.
or 7B, 67.5.
Wow. Okay, so that's a pretty big difference.
Yeah. It's not just like a small improvement. It's a significant jump.
So all these like insights, all this research they did, it's actually paying off.
Yeah, definitely.
That's cool.
And then, of course, there's the top of the line model, Apollo 7B.
Okay, yeah. This is the one that's really pushing the limits, right?
This one's a beast. Setting a new standard for 7 billion parameter models. And get this, it's even surpassing some models with over 30 billion parameters.
No way.
That's
Crazy.
Yeah.
We're talking like Oryx 34B, Vela 1.540B. These are massive, massive models. And Apollo 7B is beating them on several benchmarks.
So wait, on MLVU, Apollo 7B got 70.9, right?
Yep.
And Oryx 34B, which is like way bigger, got 70.8.
That's right.
So even though it's smaller, it's still winning.
It shows you that you don't always need to just like throw more computing power at the problem.
Sometimes it's about being smarter, not just bigger.
Absolutely.
Okay, so Apollo's a champ, in the AI world, but like, what can it actually do?
Well, one of the things is it can analyze those complex visual scenes, not just recognizing objects, but understanding how they relate to each other.
Okay, so like, imagine we showed it a clip from a cooking show. What could it tell us? Well, it could identify all the ingredients, figure out the steps, in the recipe, and understand like why is the chef doing this? Like, oh, the chef added flour because the dough was too sticky, and maybe even anticipate, what they're going to do next.
That's crazy. So like an AI sous chef
Yeah.
that actually understands what's going on.
Pretty much, yeah.
And it's not just cooking, right? This could be like anything.
Right. Sports, understanding player strategies, maybe even predicting their movements. Help coaches, commentators, maybe even prevent injuries by identifying risky moves.
That's amazing.
Yeah.
What about medicine?
Oh, yeah, definitely.
Yeah.
Doctors could use it to analyze those medical videos like surgeries.
Yeah.
Maybe spot things that a human might miss. Earlier diagnosis, better treatments, even training, helping medical students learn.
Okay, so the applications are kind of limitless.
Yeah, as this technology gets better, I mean, who knows what we'll be able to do.
Yeah. So, okay, we've seen what it can do, but like, how did they train Apollo to be so good? What was the secret sauce?
Well, the data they used was a big part of it. They didn't just use random videos.
Okay.
They carefully selected a huge data set of, text, images, but of course, a lot of videos, different types.
So it's not just about video data, it's about giving it a good mix.
Right. And they even made their own multi-turn video-based conversations. Imagine, like, you're showing the AI a video and you're having a back and forth conversation about it.
Okay, that's interesting. So you're like teaching it to think critically about what it's seeing.
Yeah, and communicate its understanding.
Yeah.
Like a person. That's pushing the limits of training. It's not just feeding it data, it's teaching it to think.
So the training process itself, was that pretty straightforward?
No, definitely not. Remember those training stages we talked about? They're like carefully designed to unlock different parts of the model. Like, teaching a kid to ride a bike. You start with training wheels, then you take them off as they get better.
Yeah, that's a good analogy.
One of the things they found was this progressive unfreezing.
Yeah.
They start with the connector, then the vision encoder, and finally the LLM, the language model. And that gives the best results. It lets it learn in a much more structured way.
So like building a house, you start with the foundation, then the walls, then the roof.
Exactly. And then the types of data, like finding the right mix of text, images, videos. That was key too.
Okay.
They found that around 10 to 14% text data was important to prevent the model from forgetting what it learned before.
So even though the goal is video, you still need some text to keep it sharp.
Right. And when it came to the visual data, a slightly video-heavy mix worked best. More videos than images.
Makes sense. If you want to train a marathon runner, you make them run marathons.
Exactly. More video, deeper understanding of how video works, how to tell a story visually.
So all these little things, they all came together to create Apollo. And it's really changed the game for video understanding AI.
Yeah, it's a huge step forward.
But, I mean, there's got to be more, right? More challenges, more to explore.
Absolutely, yeah. There's always more to do. Even though Apollo is already doing some pretty amazing things, the authors are already looking ahead, identifying the limitations and thinking about the next steps.
So they're not just like sitting back and celebrating. They're already thinking about like, okay, what's next?
Right, exactly. Always pushing forward. And one of the big things they highlight is the need for better ways to evaluate these models. Remember how we talked about ApolloBench?
Yeah, how it's like a more rigorous test.
Right. Make sure the AI is not just like cheating, you know? But even ApolloBench has its limitations. Most benchmarks, including ApolloBench, they mostly rely on multiple choice questions.
Which, I mean, makes sense, right? It's a pretty easy way to test if the AI can pick the right answer.
But it doesn't really capture like how these models could be used in conversation. You know, like imagine actually having a back and forth with an AI about a video,
Yeah.
asking it follow-up questions,
Yeah.
getting it to explain its thinking.
Okay, yeah. That's a whole other level of understanding. It's not just about like picking A, B, C, or D. It's about explaining why you pick that answer.
Exactly. And that's the kind of interaction we want.
Mm.
But to get there, we need better benchmarks that can actually test their conversational abilities.
So it's like moving from a written test to like an oral exam where you have to like actually defend your answer.
Yeah, exactly. We need benchmarks that can assess like how well the AI can stay on topic throughout a conversation, you know, how it responds to new information and how it uses language to explain what it's seeing.
Okay, so moving beyond just like simple Q&A to something that feels more like, a real conversation.
Right, a real dialogue.
And what about like the actual technical side, like how these models are built? Are there any areas where they see room for improvement there?
Yeah, definitely. They talk about some really interesting directions for like model architecture and training.
Hmm.
Right now, most video understanding models use these things called transformers, and they've been super successful, especially in language processing.
Yeah, they're like the superstars of the AI world right now, right?
But, you know, the authors are suggesting that maybe we should look at other types of architectures, you know, ones that might be even better suited for video.
Okay, so not saying transformers are bad, just that maybe there's something even better out there.
Exactly. Like, for example, they suggest looking at graph neural networks.
Okay.
These are really good at representing relationships between things.
Yeah.
Like the connections between different objects or events.
And that's obviously really important for understanding video.
Right. And then for training, they highlight the potential of using reinforcement learning.
Reinforcement learning, isn't that like where the AI learns through trial and error?
Yeah, you can think of it like training a dog. You know, you give it a treat when it does something good.
Right. So you could use that to train these AI models to like be more strategic in how they approach video, right?
Exactly. You give it a goal, and it learns the best way to achieve it. It gets rewarded for making good choices and penalized for bad ones.
So it could learn to like pay attention to the right clues, the important details.
Yeah, and it makes the models more adaptive, more creative.
That's cool. So the research behind Apollo, it's groundbreaking.
Definitely. It's changing how we think about video understanding AI.
But, it's really just the beginning.
Yeah. As we develop new benchmarks, new architectures, new training methods, we could expect to see even more amazing progress in this field.
So what does all this mean, for everyone listening? We've talked about all these examples, cooking shows, sports, medicine, but those are just like scratching the surface, right?
Yeah, the possibilities are almost endless. Imagine, AI that can personalize education, based on how we interact with videos, or revolutionize customer service,
Yeah.
just show them the problem instead of trying to explain it. What about entertainment, like immersive experiences that blur the lines between reality and fiction?
Yeah, it's mind-blowing. And as this technology gets better, it's going to touch every part of our lives.
Yeah, I think so. And before we wrap up, I just want to say, the authors of this paper have done some amazing work. They've uncovered some really incredible things about how AI can understand video, but the most exciting discoveries are still out there.
Yeah, so, to everyone listening, think about the potential, think about the challenges, and think about how you might be a part of this. What will you imagine? What questions will you ask? What will you contribute?
The future of this technology is really in our hands, and it's a future full of incredible possibilities.
That's a great point to end on. Thank you for joining us for this deep dive into the world of video understanding AI. It's been a fascinating journey, and we can't wait to see what the future holds.